Okay, so today we're going to solve a more complicated equation. I gave you a simple one before. It's in the class notes. It's very easy to do by hand. This you cannot do by hand. It's impossible. There's no way to solve this using algebra. So what you have to do is take everything on this side, radical 7 minus x, and put that in your calculator as y1, and take everything on this side and put it in the calculator as y2. And I'm going to graph this one, and I'm going to graph this one, and I'm going to see where they meet. The point where they meet will be the solution. They might meet once, twice, three times. You don't know until you draw them. Okay, so we're going to draw them together in a second. So we are going to try to solve the equation I wrote up there. So the first function I have to put in is square root 7 minus x. So I'm going to hit second. And then the x square opposite is radical. So the radical is down there. You have to hit second first. So now I'm going to hit 7, take away x. That's going to give me the first dude. Hit enter. Now I got to put x to the third. So I put x to the third. Come out of the power, which I didn't do before, minus 2x squared. And then take away 7, right? And then hit enter. Make sure your window is 10 by 10, but I'm looking down over here that my window is 10 by 10. So I'm going to hit graph at this point. So there's the square root graph being drawn. And that's about what it looks like. It's got a negative, so it's flipped. Now, what I was trying to say when my audio cut out on me was, you have an x to the third graph here. Now, you might wonder if the graph comes all the way down and swings back up off the screen where you can't see and hits the graph. But this is why I taught you about the end behavior of a function. X to the third is odd. And that means that the ends of the graph will go in opposite directions. The ends are not going to both point up. One will point up and one will point down. So I know these graphs are not going to hit again. I also know the x to the squared graph continues in the direction it's going. It's not a parabola. It's not going to all of a sudden swing back around and hit the other graph underneath where I can't see. You can always zoom out super far if you're really paranoid that you missed a spot where they meet. You're going to see, I'm going to do another example where they'll meet off screen and I do have to mess with the window. But for right now, what you see is what you get. They only meet in that one spot. So I'm going to hit second, calculate. Now we have value, 0. We did zeros. We did max and min. We're down to number 5. So you can scroll the thing down or you can just press the number 5. So I'm looking for where the graphs intersect where they meet. So the flashing thingy is there. Now it says first curve. What you do is take the flashing thingy and move it close to where they meet and then hit enter. The flashing thingy now jumps to the second curve. So just move it again closer. Hit enter one more time and it should land me right on my spot. So it says x equals 3, y equals 2. Now, which of those is my answer? Well, I'm solving for x. My original equation had x's in it. So my solution, sorry, is x equals 3. Let me screw it up some more on this side. So this is the answer. This is the solution, x equals 3. They don't meet. And then you say, well, what the hell about y equal 2? This is the number you get when you plug 3 into both sides. And you're going to see, because I'm going to do it when I go back to switch back to the board. All right, so back to the board. I used the calculator and I saw that when x was 3, these two graphs met. They intersected at that point. Now, if you put 3 in this side, right, you would have radical 7 take away 3, which is radical 4, which is 2. If you put 3 into this side, right, 3 to the third, I'll try to do this fast. 3 to the third is 27, right? 3 times 3 times 3. This is 9 times 2, which is 18. Take away 7, right? So that's 27, take away 25, which is 2. Yay, both sides are 2. So this is the number you get that makes the left side and the right side equal. Hence, it is the solution. I don't care about the 2. What the hell is 2? 2 is the number that you get when you plug in 3. That's nice, but this is, my solution is 3. My solution is not 2. I don't plug in 2 to both sides and they're equal. I plug in 3 to both sides and they're equal. So this is important to understand when you get this answer, that you are only looking for the x coordinate of the point where they meet. That is your solution. It has nothing to do with the y. Later. All right, so this is the second example. This time I have an absolute value with an x squared in it. This is a really funky graph. And then I have another x third. And remember, x third usually looks something like this. So I expect that from this side. This side, I have no idea what the hell it's going to look like. But I'm going to graph them both. I'm going to put this one again as y1. I'm going to put this one as y2. I'm going to graph them both. I'm going to see where they meet. And then that'll be my solution. Okay, so the top one, I cleared out the calculator. I didn't have to mess with the window on the last one. So on the top function I had that I'm going to put for y1, I needed absolute value. So in case you forgot, you hit math, you go over to numbskull, and it's the very top one, right? So you hit enter, and it should get it. Your calculator will either say ABS for absolute value, or it'll give you the bars like it gave mine. All right, so let's say I got x squared. So put x squared minus 9x minus 3. That was what I had written on the board for y1. Now on the other side, I had x third again. So I had x raised the power to the third. Remember, when you want to put the next thing, come out of the power. Press the little side thingy to the right, and it comes out of the power. And then you hit plus x, or else that plus x would be up there with the 3, and it'll give you something monstrously different. Take away 6. So I had x third plus x take away 6. That was my second dude. Now I'm going to graph them. Keep my fingers crossed. See what they look like. It's like, woo, okay. Follow the bouncing ball. X third looks similar to what I was expecting it to look like, right? That kind of, it starts down and it just goes up, up, up. But my window's no good. They're definitely going to hit somewhere, but the question is where. I have no choice to mess with my window. Now I'm picky about this. You don't have to go nuts like I'm doing. I'm going to actually change my X's to 8. And I'm actually I'll keep the scale. Okay, so now I'm going to change, Y min is okay. They meet somewhere off the screen and I'm not sure where. So I'm going to change my Y max to 20. And I'm going to try again and see if I got the top point. I missed it just barely. So you got to go a little higher, right? This is what you're going to do. This is why I'm showing you this. Well, I'm going to make it 30 this time. Notice that each time I change one of my things, I change the scale. What does the scale do? Instead of counting the y-axis by 1s, I count it by 3s. It just looks a lot messier if you don't do that. Aha. Well, there we go. All right. So the absolute value graph is really funky. I mean, it's kind of like, it comes down and then goes like a parabola and then goes back up. It's weird looking. So I want to see where they meet. They're not going to meet again, right? There's the x third graph continues down and up, and it's not going to double back. And the same thing, this absolute value is like this weird W. So I hit second, calculate. I hit press 5 for intersect. It says first curve. Just really simple. Move the flashing thingy next to where they meet. If they meet in more than one place, you have to do this twice. So you go kind of close to where they meet, you hit enter. It jumps over to the second curve. You don't have to move it again. You can actually leave it right where it is, but I'll move it again. You hit enter one more time, and then it takes me right there. So I get, this time I don't have a nice answer. And I'm not going to double check this answer by hand. This is where they meet, 2.873. Yeah, that's nice. Again, this is not something you could do by hand. You have no choice but to put them in the calculator and see where they meet. And that is your solution. Okay, so that's all you have to do. You put the left side as y1. You put the right side as y2. You draw them. Make sure that you see where they meet in the window. You may have to mess with the window to make sure you get where they meet. And then after that, second, calculate and intersect. And then you're good to go.